Hello, hello everyone. I'm Dan Facondorin from BIT Mega 3A. So today's video I will discuss the four components of refrigeration cycle. So the first components of refrigeration cycle is compressor motor. The second one is the condenser. The third one is the expansion valve. And the fourth one is the evaporator. So we will discuss the first component of refrigeration cycle. The first component of refrigeration cycle is the compressor motor. So what is refrigeration? What is compressor motor? So the compressor motor is the first step of the refrigeration cycle, and a compressor is a piece of equipment that increases the pressure of working gas. Refrigerant enters compressor as lower temperature gas and leaves the compressor as high pressure, high temperature gas. And it have a types of compressor. The first one is the reciprocating compressor. The second one is the scroll compressors, and the third one is the rotary compressors. So these three is the several compressor designs are used in the HVAC refrigeration today. So the next component of the refrigeration cycle is the condenser. So what is the condenser? So the condenser or the condenser coil is one of the two types of the heat exchanger used in basic refrigeration loop. This component is supplied with high temperature, high pressure vaporized refrigerant coming from the compressor. So the condenser remove heat from the refrigerant vapor until it condenses into a saturated liquid state, aka condensation. So after condensing, the refrigerant is a high pressure, low temperature liquid, at which point it's routed to the loop's expansion device. This is the expansion device that I will discuss after the condenser. So the next components of the refrigeration cycle is the expansion valve. So what is the expansion valve? This expansion valve comes in a few different designs. Popular configuration include fixed or refixed thermostat expansion valves, or PXV, or thermal expansion valves, and more advanced electronic expansion valve, or EEVS. But regardless of configuration, the job of this expansion valve is the same a drop pressure after the refrigerant leaves condenser. This pressure drop will cause some of the refrigerant to quickly boil, creating a two-phase mixture. This rapid change is called flushing, and it helps tee up the next piece of equipment in the circuit, the evaporator, to perform its intended function. And the last components of the refrigerant cycle is the evaporator. This is the evaporator. So what is the evaporator? The evaporator is the second heat exchanger in standard refrigeration circuit, and like the condenser, its name for its basic function, it serves as the business of refrigeration cycle, given it does what we expect air conditioning to do, absorb heat. This happens when the refrigerant enters the evaporator as the low temperature liquid at low pressure, and fan forces air across the evaporator fins, cooling the air by absorbing the heat from the space in question in the refrigerant. So after so after 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 that after I discuss the four components of aircon refrigeration cycle, I will discuss this diagram, how will it how it will work how will it works. So 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 the refrigeration so the refrigeration cycle is a complex process essential for any system function. So it begins in the compressor motor, which compress refrigerant gas, resulting significant increase in both temperature and pressure. Typically, this compression raises temperature at the range of 54 to 60 degrees. 54 to 60 degrees. So 54 to 60 degrees. Then when the pressure reaches the level between 350 to 500 psi, or pounds per square psi, pound square inches, so 350 to 500 pounds per square inch. So as a consequences, the refrigerant transform into high pressure temperature gas, and it's directed through copper tubes. So this is the copper tubes toward the condenser. Entering condenser, high pressure temperature gas releases heat surrounding the crucial heat exchange causes of refrigerant shed thermal energy to 50 to 63.80 Celsius to 63.8 to 57.7 degrees Celsius. And leading the condensation, the transition from gas to high pressure liquid. Throughout this condensation process, the pressure within the system remains within the range of 270 to 380 pounds per square inch upon the passing through the expansion valve. This is the expansion valve. So the high pressure liquid refrigerant enters the evaporator. Expansion valve. The pressure liquid refrigerant enters the evaporator to with heat of 46 to 66 degrees Celsius to 55 to 12.2 degrees Celsius, where experience a further pressure drop levels between 45 to 65 psi. Inside the evaporator, the refrigerant uh, inside the evaporator, the refrigerant main task will absorb heat from the substance or space being cooled. This absorption of heat causes the refrigerant evaporate into the low pressure gas, thus completing the refrigeration cycle. So this continuous process for allows for the efficient transfer to heat from the location to another, enabling refrigerators, air conditioner, and heat pumps to maintain cool temperature in various environments. So that so that the so that's the video of the that's the discussion of the video, discussion of the diagram. So after discussing this diagram, I will discuss the compressor, condenser, expansion valve, operator in the aircon, in the real aircon. So I will discuss in the aircon how it will work, the evaporator, the compressor motor, the condenser, and the evaporator.
Everyone, I'm John Colondres from VIT Mechanic. So I will discuss the four parts of air conditioning refrigerant. So the first one is the compressor. The second one is the condenser, and the third one is thermal expansion valve or capillary valve, and the last one is the evaporator. So 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 this is the compressor. The function of this is to compress the freon, and the freon travel to this cover tube and through condenser, and the condenser makes the freon high vapor, and that high vapor is 300 to 500 psi, and that high vapor travel this U copper pipe, then travel the high vapor to capillary valve or thermal expansion valve, and when the high pressure vapor travels in thermal expansion valve, the high vapor turns to low 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 vapor, and that low vapor travels to low vapor travels to evaporator. So the evaporator have a rotary fan, so that rotary fan, and this exhaust exa- this exhaust sucks the air in the atmospheres, and the rotary fan through, flows the air to these exhaust and make the air cold.
So this is the so this is the diagram. Diagram. This is the compressor motor. Outlet side, so motor and evaporator. Ano po sasabihin ko? Ano po sasabihin ko, guys? So sequence of the device.